Migrating millions of lines of code to TypeScript. On Sunday, March 6th, we migrated Stripe's largest JavaScript codebase, powering the Stripe database from Flow to TypeScript in a single pull request. We converted more than 3.7 million lines of code. The next day, hundreds of engineers came in to start writing TypeScript for their projects. That's a big-ass PR. Seriously unreal. I remember a short time ago laughing at the idea of TypeScript ever landing at Stripe, and then I woke up Monday morning, and it was here. Thanks, Mike Fix. TypeScript is the de facto standard for JavaScript type checking, and our engineers have been overjoyed by this migration. We are sharing our TypeScript conversion tool on GitHub to help others perform similar migrations. Okay, so they are obviously going from Flow to TypeScript. By the way, this should be just a good little mental note for everybody. The next time you're hyped up about the greatest and latest JavaScript thing, just remember that for every person that gets hyped up about some latest and greatest TypeScript JavaScript thing, there's a company 5 years down the line trying to figure out how the hell do we get off of this old ass janky piece of shit system that somebody, that was great at the time but now sucks. Just remember that. Just remember that most React today are still classes. Legacy systems are real, people. Functional components came out like 8 years ago. And people are still it's just classes. Classes everywhere. I think a lot of people forget just how long software can be around. When you write software, you write it as if it's going to be around for a year, and 90% of the time you're right. The other 10%, it's around for 20 years. And you have COBOL still exists for a reason today, people. If you just don't believe that, just remember, go look at COBOL, and then you'll remind yourself, oh yeah, that's why. Stripe has built a large-scale front-end application since 2012, including Stripe.com, Stripe.js, and Stripe Dashboard. As our company grew, we increased the quality and reliability of our products by type checking our JS code. In 2016, you should put the word linting actually. Okay, let me just put my fedora. In 2016, we were an early adopter of Flow, an optional type system for JavaScript developed at Meta, then Facebook. Since then, Flow has provided type safety for the majority of our front-end applications. I have never actually really seen much about Flow. Is this Flow? Well, so far it looks the same. I wonder what that plus sign means. Example of generating flow type from an API resource and associated endpoints. Okay. However, engineers had trouble working with Flow. The type checker's memory usage would lock up laptops. There's something so beautiful about this. Remember, TypeScript is huge. All right, when you run TypeScript, like if you run Jest, right now, if you go and run 2 separate files on Jest, with TypeScript, you'll probably use 2-3 gigabytes of memory, unironically. Here, I think I have this thing around here, Jest test. Yeah, I can't remember how to actually run this bad boy. Cat package. Was I smart enough to leave myself any breadcrumb? No, I wasn't. Let's go like this. npx jest. Oh yeah. I left it around. Oh yeah, we left it around, boys. All right, so I'm gonna take this thing. I'm gonna grab this little thing right here. Don't worry, it runs for 45 seconds. It has a 45-second wait. Personal VMRSS, paste that in. There you go. Look at that. Here's the best part is this is like a generated small little project right here. I'm running 2 tests. Look at all those empty node instances for no reason. This is just how many cores my computer has. It's 1.1 gigabytes on nothing. It's 2 tests, plus a whole bunch of just empty things running. This is what Jest runs. This is Jest. Run Jest, which runs a shell, which runs Node, which runs the amount of processes you have as nodes. The in-editor integration was frequently slow and unreliable. Meanwhile, TypeScript, an alternative type system developed at Microsoft, exploded in popularity thanks to its tooling and a robust community. TypeScript availability became a top request among engineers at Stripe. TypeScript, the LSP for TypeScript is pretty good. It's fast. It mostly works. There's some gripes one could have about it. Like one thing that's really difficult, like if you've never worked in another language, you may not realize some things that are really awesome. And so one thing that you may not know, if I'm in here and I'm working on a project right here, right? And I delete this and I run trouble, I will get every single file in which I just broke. Okay? Here's every single file that I just broke with that thing and some breaks that I just have. If you're in TypeScript land, what's going to end up happening is that only the files you've told TypeScript about are they going to do. And if you have a smarter system that actually does it for you, it's really hard to say what files should TypeScript tell you is broken, because TypeScript itself doesn't have the knowledge of the bundler, because you have to know where your entry point is, what's running right. Like there's like a lot to it. And so you'll get these kind of weird experiences. TypeScript's great. It's much better than the alternative, but it's also difficult. You don't get the whole thing. Like Go's also really great, right? You go, you make a small mistake in Go, and it'll tell you everywhere immediately in like 0 seconds. It's great. It's a good experience. TypeScript is at least a second-rate great experience, which I think is a dramatic improvement in JavaScript land. Stripe's developers productivity team aims to provide our engineers with the most productive development environments of their careers, and delight in our tools are crucial for that. We work hard to identify the most pressing issues affecting developers. For example, we've built integrations into all of our development tools for reporting friction. Oh, that's kind of cool. I think this is really cool. I love the mentality. If you were a company of 3 people, this is not important. If you were a company of 30 people, 50 people, 100 people, this is so important. The care for internal tools is just so hard to sell, but it is such a multiplier in productivity. You just have to, like, LSPs are not hard to create. Lean into it. You have some proprietary configurations, build an LSP. Link out to documentation. Make it easy for people just to use you internally, right? Like just go all in on it. And so like for me, it's just all about that, which is how well can you build internal tools? And so I just love this. I absolutely love that they're taking it. Most importantly, it makes Stripe sound like a cool place to work, honestly, which is quickly routed to the responsibility teams and prioritized. TypeScript support was one such pressing issues, and teams supporting front-end engineers began to plan out supporting TypeScript across the company, choosing the right migration strategy, which was all of it at once. Our largest front-end codebase powers the Stripe dashboard and other user-facing products. The dashboard codebase has tight coupling between disparate components and no cleanly factored dependency graph. An incremental migration to TypeScript would force developers to work in both languages to accomplish common tasks. We would also need an interoperability layer to sync between definitions between both languages and keep them consistent throughout the development process. That's a yikes from me. Prime got a different definition of friction. He's moving so lightning fast that friction, going to friction. I'm not even sure what that means, to tell you the truth. In late 2020, we formed a new horizontal JavaScript infrastructure team, a group of engineers solely focused on elevating the experience of writing JS at Stripe. One of the team's first challenges was to replace Flow with TypeScript with a long and uncertain migration. We began speaking to companies who had ran into similar migrations and reading articles from Airtable and Zapier describing their experiences. These companies developed automated scripts to convert one language to another, ran them over their entire code bases, and merged that output as a single commit. Airtable had published their conversion script to GitHub as a source-to-source conversion tool, or CodeMod, that would parse Flow. I mean, this is super cool. I absolutely love this. I did a semi-similar experience. I don't need it anymore, but I had this really annoying problem at Netflix where I had this untyped database, Mongo database, by the way, and it would just send down just gallons of just JSON objects. So I made something called undefined, in which would take all of the objects. I'd feed it like 3 million objects, and then it would like union and collapse and create, and then you could start naming it and config each one of the names, or else it'd just give you like event 1, event 2, event 3, or whatever you wanted to call it, and it would just build out this entire definition based on a huge amount of just untyped JSON. Very fun. It was a fun project, but generating types is hilariously fun, can be great, but man, is it also a pain in the ass. I can't imagine Flow to TypeScript. I'm sure there's these weird edge cases that are super annoying. Migrating in this way would greatly reduce the cognitive overhead for engineers who would not need to handle both type systems for the same product behavior. We could have a clean break between Flow and TypeScript. Imagine the next day, like after you put this in, imagine what would go and how many bugs you'd have to deal with over time. So you're saying you built QuickType. I don't even know what QuickType is, but something like that. Only Prime would name a project undefined. Yeah, it was me saying I hate you. Because the best part is that when you require it in, you have to require in undefined. Super funny. We are really impressed by the quality of Airtable's conversion code and decided to use that as a basis for our migration efforts. Many thanks to the team at Airtable for building this out and sharing their work. The open source community benefits a ton from examples like this. We began by copying Airtable's code mod to Stripe's mono repo to run against our internal code. Our JavaScript projects make heavy use of Sail, a shared design system of strictly typed React components. I don't know what this means, so that was our initial area of focus. We generated TypeScript definitions for Sail rather than converting the code to TypeScript. It would continue to support applications definitions written in Flow. To safely support both type systems, we wrote tests to verify that TypeScript definitions against any changes to underlying Flow code. This approach would be too cumbersome for a large code base, but thankfully, the sail component interface is explicit and quite rigid. From the outside, this just seems crazy. The core code mod was solid, but not comprehensive. For many files, it would crash to generate imperfect output. Over several months, we iterated to handle most syntactic and semantic edge cases. For one example, JavaScript arrow functions can return a single expression without a return statement, such as the following. Yeah. JavaScript object literals uses braces to wrap the definitions. Because those braces are used to delineate blocks of statements, returning an object from an arrow function requires an additional... Are they not using some sort of, parsing tool? A Sprema or whatever people use these days? We noticed that CodeMod was incorrectly stripping the extra parentheses from these arrow functions, but only in the case of generic functions, a function that takes a type argument, which is syntax not available in standard JavaScript. By the way, I would say the bad isn't that it's not being handled properly. It's the fact that people gotta stop. I am perplexed at the usage of arrow functions. I am, okay? I'm perplexed by the usage of arrow functions in const like this. I guess I just don't understand it. It's not even like it's smaller, right? It's not like function foo. It's not like you're saving code. You're not doing anything more glorious here. What are you buying here? What are you buying here? Yeah, if you're doing this, I would have so many questions. The chainer's it makes sense if you're doing something like array.map, right? That makes sense, right? We can all agree, okay, this is a good use of an arrow function, but you're defining it like a function. That's what I don't understand is you are clearly creating a function. I just don't get it. Hoisting? No one relies on hoisting. None of that makes any sense. Standard languages for the last forever, every language other than C, when you define a function X, it is expected to be within the scope of X. That's just an expectation. So you can call X here, you can call X here. This is just it's in Rust. It's in other languages. People just expect these things to exist. In fact, it's super annoying when you have to define your functions in order. Making it named function gives it better error messages. It does. It's nice. People love ligatures, right? I don't understand why. I get it for, you're just having a small anonymous function or you're actually using this. There's a real reason this. It makes sense. I just don't understand it as a top level function. It's just yo bro, just write function. You're not buying anything. Once sail was unusable from TypeScript, we worked on a couple internal applications containing hundreds of JS modules. We also added a second pass to CodeMod to suppress errors in the generated code using TypeScript's TS expect error comment to tag these errors. Rather than resolving every error ahead of time, we focused on eliminating flow as soon as possible, tracking TypeScript error suppression to address the conversion. After initial pass on the dashboard codebase created over 97,000 error suppressions. With our iterative approach updating the CodeMod, we were able to get that number down to 37,000, or about 1 per 1,000 lines of code. 37 million lines of code? Did anybody else catch the 37 million lines of code? What the hell are you building? You'd have to type a line of code a second for a year and a half to get that much. 1,000 times 1,000 is a million. So 37 1,000s would be 37 million. Just add 3 zeros, dog. Just add 3 zeros right here. Obviously they don't count node modules because node modules aren't in Flow. Man, this is complete. Dude, Rich clearly is here. Rich and Brad and Tom combined made 37 million. That's just crazy. I'm having a hard time fathoming 37 million anything. Okay? That's hard for me just to even think about. Both Flow and TypeScript support measuring type coverage, and we are pleasantly surprised that TypeScript reported higher coverage than Flow, even with the suppressions. We attributed that to an increase in the number of quality or third-party type definitions available in TypeScript, the lack of which was a large contributor to poor... Now I got another question about JavaScript type coverage. Here's a no-no of JavaScript that you may not know. Const foo equals JSON... Oopsies, what is it? GU, right? JSON parse, some string, right? Remember, what comes out of parse is an any. So it's do you have code coverage here? Do you have type coverage? I don't think you have type coverage. You have type assumptions. So you have to have something like Zod, right? You have to have something as Zod. A lot of people don't realize how tricky TypeScript really is because TypeScript's not tricky when you have the things defined. TypeScript is tricky at every place in which you have some sort of contact with some other world or where an any can exist. That is why we have ambient declarations to make JSON parse return unknown. Yes, I think that's Matt did that, right? He did that whole fixed TypeScript thing. That was I think that was a very good move. TS is great because it can give you a false sense of security. TS reset, that's what it is. As we moved our dashboard with its tens of thousands of modules, our approach created significant memory pressure on the TypeScript compiler. Our primary tool to address this was TypeScript project references. Although the dashboard is not structured as distinct modules, we could infer a module structure and create project references based on that. This approach gave us a headroom to run TypeScript over a code base without refactoring large chunks of application code. All this makes perfect sense. I don't think you're going to get away from the memory problem at 37 million lines of code. Like, TypeScript is going to use 20, 30, 40, 50 gigabytes of memory. I don't see how you're getting away from it. You have too much code, and TypeScript and JavaScript aren't light on memory. So it's just super hard. It's 3.7. It's a typo. How do you know it's a typo? You know what? I'm gonna believe you. It's a typo. Oh, it's in the title. Oh, nice. You're right. It is somewhere near the title. I'm not sure where it is, but I'm sure it is. You're right. It's right there. Okay, cool. But so you're right. It is 3.7 million. So it's a typo. It must be 1 per 100 lines of code. But I still have a question. 3.7 million lines of code. That's still huge. You're right. It's better. It's still crazy. All right, going live. Hundreds of engineers contributed to the dashboard each week. Such a sweeping change would be exceptionally challenged to merge in a normal working day, so our team decided to commit to a date, March 6th, a Sunday, where we'd lock the Stripe monorepo and land our branch. In the week before merging, we focused on passing a build through our CI system and deploying it to our QA environment. Although TypeScript could successfully check the project, other tools that process our source code, ESLint, Jest, Webpack, Metro, would also need updates. One particular pain point was Jest snapshot testing. Oh, really? Jest generates snapshots with a hard-coded reference to a test file that generates them. Since our code mod would generate either a TS or a TSX extension for TypeScript files, the snapshot would have invalid references back to their test sources. We simplified by switching the generated to only use TSX. This meant we could write the snapshot in bulk and keep 100% of those tests passing. I mean, whenever you do this kind of stuff, this is what you're getting, by the way. In some cases, we recognized that fixing the code of our TypeScript compatibility would add weeks to our schedule. One set of cases was our custom ESLint rules. We had a rule to reorder imports to enforce consistency between files. I hate this. By the way, I hate this. I honestly see no value in reordering inputs alphabetically. Can someone help me? What's the purpose? Helps people with OCD? You know, this is called exposure help, right? You slowly get... First off, it's not OCD, okay? You're just being an asshole, okay? There's a difference between OCD, which is a real medical disorder, and requiring other people to organize their imports alphabetically. That's just called being an asshole. There's just a big difference between the two. I don't know who's organizing imports. I have never had any... I don't understand it. Group by imports by type. Yeah, I mean, I've seen people do this, but again, like, I think all of this doesn't make any sense anymore. Let's keep on going. With passing build in hand, we reached out to our product teams with user-facing functionality in the dashboard. Although the dashboard has extensive unit and functional testing, it has limited end-to-end test coverage. This made manual testing by product stakeholders crucial. Oof. Those tests highlighted some minor bugs, which we resolved during the final week. In one case, we were failing to load any translation for non-English dashboard users due to a hard-coded .js extension in the translation landing code. Damn. That sucks. Funny, but that sucks. This process gave us high confidence, but there's always uncertainty with a change this large. Although we had a firm grasp on our developer tooling and build processes, we were mutating every file in the code base. Subtle errors in our conversion scripts. For example, removing an empty field from an object shared between multiple components. I mean, I think it's interesting. I mean, I don't know if you've ever done any sort of migration. It's really, really hard to migrate large amounts of code. And this is clear. On Saturday, March 5th, the team generated a new migration branch and ran automated scripts. When we deployed that branch to QA and repeated our validation process, including manual testing suggested by products team, we found no issues. Man, such a good feeling, people. Tell me that's not a good feeling. Thanks to our care and rigor of the previous year's work, we had no unpleasant surprises as we shifted traffic to the new code. We unlocked the repository and let developers know the dashboard was now in TypeScript. Crazy. Imagine the first try. Imagine the first try on that. That is awesome. Good job, team. The conversion was not perfect. Over the subsequent weeks, the JS Infra team addressed issues as they arose. Natural. One example we didn't anticipate was engineers reporting inconsistency between CI and local TypeScript runs. Yep, makes sense. TypeScript, we are able to use many third-party type definitions installed from NPM, and if those are updated, engineers will need to install new versions. Yep. This was different from our flow configuration, where dependencies updates rarely changed types. So we had to educate engineers about running yarn install as a debugging. Yes. I just love the fact. I just love it. I love the fact that we live in a world in which our interpreted code, you need to delete it and reinstall it regularly to ensure that you're having a good experience. Like there's something about that just tickles my fancy beyond anything else. There's still more work to be done. We know performance improvements further with our granular project references and better caching could speed up our CI runs. However, the benefits have far outweighed the bumps along the road. Engineers enjoy features such as automatic dependency imports and code completion, as well as TypeScript's community's extensive corpus of third-party type definitions and integrations. Yeah, these are all great things. Having an LSP is a good thing. Can we all agree having LSPs is a good thing? When new engineers join Stripe to write front-end code, from day one, they can be successful in a language which they are more likely to be comfortable and familiar. I really hate this statement, which is, I think, the reason why we have so much JavaScript to begin with. If you call yourself an engineer and yet you don't feel comfortable switching languages, you're not an engineer. If you're an engineer, you're solving problems. If someone said I had to use Objective-C, which I did have this happen at Netflix, I wrote a multi-threaded client in Objective-C, my first time ever. That's just life. That's called being an engineer. You have to just simply do what you gotta do. Now, if you just wanna be a React Andy, go be a React Andy. No one's gonna, live your best life, okay? If that's what you want, go do it. First try, literally first try, and it ran on iOS for 6 years, 7 years. Wrote it in like a month and a half. It was a ton of fun. I had a ton of fun doing Objective-C because I just made it fun as opposed to making it shitty. Sometimes you just gotta do what you gotta do. Anything but Java. I've had to write a lot of Java. I was the first person to spearhead metric reporting at Netflix. We had this problem where we had all of these images for all of our originals coming out, and you have all the images localized to every language showing up in production, and we didn't realize which ones were and were not. So what did I do? I took that system that we already had for fetching images, and I started putting in a bunch of reporting, and I just created an entire reporting. I called it Atlas Mantis Logger, or AML. It was monad-like. It was monadic, so you'd keep on... It was pretty fun. Had this like fun little approach we did to it, but it would allow for Atlas logging, which is like this persistent counter gauge graph, and then Mantis logging, which is real time. So you could actually just log on, put in your like computer, and it would just flow through and show you what's exactly happening in real time as you scroll through the website to go, okay, this is where we're failing. Or it would go into a persistent long-term one, so we could actually say, hey, images are identified as being missing in these languages for this video ID. Go make sure that they're there. Boom, right? And that was all in Java. That was fun. I had a lot of fun doing it in Java too. What's a monad? A monad's a burrito. When we shared our story of our migration publicly, the response was equally enthusiastic. Developers from across the industry reached out to learn more and apply the same improvements in their own code bases. To support these developers, we're sharing our TypeScript conversion code on GitHub. Nice. Nice. Aside from the particulars of JavaScript or Flow or TypeScript, our big lesson from this migration is that dramatic improvements to large code bases are possible with diligence, commitment, and optimism. We will apply that mindset to other opportunities, make our engineers more effective, and hope others do the same. Nice. I like it. This is a great article. And I think there's a lot of really good lessons here that I genuinely like. I love the idea of going for it, making large changes, trying to make people's lives better. I love the idea of having internal tools as a first-class citizen, as like this must be done, this is incredibly important. I just think that is such good companies. I get the Pareto comparison. Yeah, you got your outside and your inside. You know what I mean? I don't know. Everyone keeps calling monads burritos. I don't understand it. But anyways, I like the horror stories instead. Yeah, horror stories are good, but horror stories you learn just as much from as good stories. This one had a really good meaning and a really good takeaway, which is we really should take internal tools and internal tool teams as seriously as any product-facing team. Because any internal team that has a lot of support will produce tools that create user-facing teams to be significantly more productive. And at the end of the day, that is what you're concerned about. Reliability and features. The name is the Primogen.